Find all solutions of 4 times sine theta plus 1 equals 0. To isolate theta, we first need to isolate the trigonometric function with theta, which is sine of theta. We do this by first subtracting 1 from both sides of the equation to get -1 on the right hand side. We then divide by both sides by 4 to get sine of theta equals -1 over 4. -1 over 4 is not one of those nice or special coordinate that we see for the special angles on the unit circle. What this means is that to find theta, we would have to use inverse sine. We take the inverse both sides to get theta equals sine inverse of -1 over 4. In radian mode, we would get -0.2527 rounded to 4 decimal places, or any number of decimal places that we need. If we round it to 2 decimal places, then this would be -0.25 only. When we use sine inverse, we are given an angle in the first or the fourth quadrant only. On the unit circle, sine is defined to be the y-coordinate. In this case, the y-coordinate is -1 over 4, so we draw a horizontal line, y equals -1 over 4. We see that this line intersects the circle in the fourth quadrant, and the angle theta that the calculator or the inverse sine give us is that this theta is -0.2527. There are infinitely many angles that satisfy this equation. We use sine inverse as a tool for us to find theta, but there are infinitely many theta that satisfy the given equation. There is no restriction on theta in the given equation. There is a restriction on theta when we've used the inverse function, but after that, we still need to find all other solutions, and we see that there is another angle in the third quadrant that will give us sine of theta equals -1 over 4 as well. Using symmetry, if going from the positive horizontal axis to this first point has a measurement of 0.2527, then going from the negative horizontal axis to the second point also have the same magnitude, and that has to be 0.2527. So the first angle in the interval 0 to 2 pi, positive angle, has to be, we start at pi and we add 0.2527 to get an angle in the third quadrant. And then for the angle in the fourth quadrant, as of now, it is -0.2527, but if we want a positive angle, then we will take 2 pi minus 0.2527, and these are the two angles in the first rotation, 0 to 2 pi. We then add 2k pi to each of these solutions to obtain the general solution. Theta equal to pi plus 0.2527 plus 2k pi. The second solution, theta equal to pi minus 0.2527 plus 2k pi. Although this is a decimal number, we will combine pi with 0.2527 to obtain another decimal number. The same with 2 pi minus 0.2527. We see that the general solutions are therefore theta equals pi plus 0.2527 is 3.3943. We still need to add 2k pi. Theta equals 2 pi minus 0.2527 is 6.09 M98s0704. We still need to add 2k pi. And these are the approximation, not exactly equals because we rounded the numbers to 4 decimal places.